in the word, when we look at the word indices, there are something you know about the indices already. That's the same thing we need to apply now also. But here the external thing would be the inclusion of logarithmics. We know the indices separately and logarithmics separately as well. Now our task to combine both of them together to work on our problems. For an example, when I explain a question related to indices, first of all, I have 2 to the power of 5 multiplied with 2 to the power of 3. Okay, 2 to the power of 5 multiplied with 2 to the power of 3. As we already know that when we deal with the question 2 to the power of 5 multiplied with 2 to the power of 3, here you can see the bases are same. Okay, this would be our base and this is our index. The bases are same, no? Here the base is 2 and here also the base is 2. When we multiply two indices with same bases, okay, with same bases, here and here both of the bases are same. When we deal with these cases in our answer also, okay, in our final value also, the base would be same as the previous one. Okay, I'll repeat it again. If there are two same bases, when we operate a question with two same bases, in our answer also the base would be same. Okay, here the operation would be multiplication. Okay, when we multiply two same based indices, the multiplication, okay, the multiplication that will become an addition in our index form. In our index form, we know that already from our grade 9 and 10 knowledge. Okay, 9 and 10 knowledge, it's very easy. Base are same. When there is any multiplication in between same bases, you should add the powers. Add the powers to finalize your answer. So it would be 2 to the power of 8. Okay, 2 to the power of 8. Not only this, I'll explain one more question. When we have 10 to the power of 4 multiplied with 10 to the power of 3 multiplied with 10. What it means? We need to multiply 3 10 based indices. 10 based indices. In all three cases, the bases are same. So in our final answer also, the base would be 10 as it is. So here the operation between these indices would be multiplication. So in multiplication means when we convert that indices to logarithmic form, that multiplication will become an addition. So 4, here we have the power as 4, index, power, all these mean this the value on top. Okay, value on top, 4 plus 3, and here I didn't indicated any numbers for here. We know that when we deal with only a number without any indices, we can conclude it has a 1. We can conclude it has a 1 likewise. So 4 plus 3 plus 1, it would be finally 10 to the power of 8. 10 to the power of 8. This is the thing about indices. Okay, this is the thing about indices. Now we are going to apply the same thing to our logarithmic as well. Okay, next thing I explained about the multiplication. Same thing applicable for division as well. Let's discuss them quickly. 4 to the power of 5 divided by 4 to the power of 2. That means the bases are same. Okay, when we operate with two indices, the bases are same. So in our final answer also, the base would be 4 as well. If there is any division, we need to subtract the indices. We need to subtract the indices. So from 5, you should subtract this 2. From 5, when we subtract this 2, that will give you 4 to the power of 3. 4 upon 3. 4 to the power of 3. This would be the answer. Okay. And one more question. We know how to operate with multiplication and division separately. When both combine together, how can we deal with that one? Okay. For that, let's try another question. Here you have 5 to the power of 7 multiplied with 5 to the power of 2 divided by 5 to the power of 5. Okay, this would be the question. Before starting to do the question, you should understand what is happening over here. 5 to the power of 7 first multiplied with 5 to the power of 2. Okay, 5 to the power of 2. So, let's make this one little easier. Okay, otherwise it looks complex one. Let's make it easier. So 5 to the power of 7 multiplied with 5 to the power of 2. So 5, here we know that the bases are same, while multiplication we need to add our powers. So 7 plus 2, it will become 9. 5 to the power of 9 divided by 5 to the power of 5. Okay. In denominator we have 5 to the power of 5. That means this is a division. In division, what do we need to do? Before starting to do the division, you should check whether the bases are same or not. Here the bases are same. So 5, here the power is 9. Here our power is 5. So 5 to the power of 9 minus 5. Division means subtraction. So finally, we will have 5 to the power of 4. 5 to the power of 4. This would be the final answer for the question. Okay, in our first question, there is a multiplication, thereafter there is a division. Let's do the multiplication operation first. So 8, base 8, the power would be 5 plus 3, it would be 8. Divide by 8 to the power of 2. Okay, division means you should subtract your indices. So 8 is, the power would be 8 minus 6. 8 minus 2 is 6. Mostly students know how to do these questions, but at that moment they will forget and they will multiply. Here in between we have a multiplication mark, no? So they will multiply these two and divide with these two, and 8 to the power of 7.5. 7.5. We might encounter many answers like this, but this is not the exact answer. When there is any multiplication, you should convert it as a division according to indices rule. Thereafter, this division will become a subtraction. Okay, that's the thing you should do. Then in our next question, 2 to the power of 2 divided by 2 to the power of 6. So the bases are same. That means from the initial power it's 2. From that, let's subtract 6. 2 minus 6, it would be 2 to the power of negative 4. 2 to the power of negative 4. It is possible to have a negative index. Okay, negative index. It's possible to have a negative index or a positive index, decimal index, even zero also possible. Let's discuss them everything in detail continuously. Okay, thereafter we have an operation over here, and in below also we have an operation. So first of all, I already told you that if there is a number without any index, you can conclude it has a 1. You can conclude it has a 1. Likewise, 10 to the power of 9 multiplied with 10 to the power of 1. That means 10 to the power of 9 plus 1, it would be 10. 10 to the power of 10. In denominator, what we have? 10 to the power of 7 multiplied with 10 to the power of 3. That means 10 to the power of 10 again. 10 to the power of 10 again. Here there is a division. Okay, there is a division. So that means 10 from the power 10. Okay, now I'm talking about the indices. From the power 10, I'm going to subtract another 10. Okay, base 10. In the index, we are subtracting 10 from 10. So that will give you 10 to the power of 0. 10 to the power of 0. That means for any number, okay, except 0, for any value, any natural value, if it has the power as 0, that will give you the value 1. That will give you a value 1.